All right, today we're going to be talking about, and you are going to be finding roots of numbers. All right, and you're going to be finding multiple roots, meaning if you're asked to find the square root of 4, all right, this is square root of 4. All right, and that's equal to positive or negative 2. We're going to move on from that today, and you're going to be asked to find cube roots, or third root of 8. You read this as cube root of 8. And the cube root of 8 that's equal to 2. Because 2 raised to the third power equals 8. You're going to be asked to find maybe the fourth root of, let's go with 16. You would read this as the fourth root of 16. And it's equal to 2 as well. And that's because 2 raised to the fourth power is equal to 16. Once you start getting above the square root of numbers, there's a button on your calculator, and it looks like it could either be a button or it could be in the background of a button. And it's the square root symbol. It's got an X where the index is located, and it has a Y where the radicand is located. Now on my calculator, I have a TI-30XA, okay? And if I'm trying to find, say, I'm going to use the third root of 8 again for an example because we already know the answer to that. So on my calculator, if I want to find the third root of 8, I'm going to type the number first that's under the radical. So I'm going to type 8. And then my button is located just below the off button. All right, my button that looks like this right here. On a TI-30XA, it's just below the off button, but I got to use the second function first. So I have the 8 on my screen. I go second that button, and then I type in the index, which is 3. So that means I'm finding the third root of 8, and I hit equals, and I get a 2. All right, so if you want to try this, try maybe the third root of 125 and see what you get. So 125 typed in, second that button, and then 3 again, hit equals, and you should get a 5. All right, the third root of 125 is equal to 5. All right, again, because 5 to the third power equals 125. Everybody okay with that? All right, almost everything that you're doing today is just going to be using the calculator to find a third root, to find a second root, or to find a fourth root. So a couple of important rules related to these different roots. One of those rules are that negatives under the radical can have only one odd root. Negatives under the radical can have only one odd root. Here's what I mean. If you're asked to find the third root of -8, there's only going to be one root here, and that's going to be -2. And that's because if you took -2 times -2 times -2, it would be equal to -8. The third root of -125 is equal to -5. All right, for the same reason. If you take -5 and you raise it to the third power, it's equal to 125. The rule that goes along with this is that negatives under the radical cannot have an even root. And what I mean by that is we've kind of gone over that already this year. If you're asked to find the square root of -4, all right, the square root of -4, there are no real roots. Because 2 squared equals +4, and -2 squared also equals +4. All right? So negatives under the radical cannot have an even root, meaning this index right here, if there's no index, it's a 2, and 2 is even. All right, so any negative under the radical cannot have an even root. When you see a negative, any negative under the radical, right? Maybe it's the fourth root of negative anything. There's no real roots. A negative under the radical, and you're trying to find an even root, there are no real roots. Okay? Only time a negative under the radical can have a real root is when you're finding an odd root. So some examples of the problems you're going to see today. If you're asked to, or what are the real cube roots of, and then we're going to be given some different values here. So real cube roots of, let's say maybe 0.008. So this is a calculator function. So we go 0.008 second y to the x and 3 again, hit equals. And that's equal to 0.2. If you're asked to find the real cube root of negative 1,000, right, that would be the same as trying to find the third root of negative 1,000. So in your calculator, you can type 1,000, negative, second y to the x, and 3. And I get a negative 10. Because negative 10 to the third equals negative 1,000. Real cube root of 1 over 27. All right, I'm going to type 1/27th in the calculator. Second, y to the x, 3, and hit equals. And we get 1/3. All right, because that's just the same as the third root of 1 over 27, which is equal to 1/3. And then you may see what are the real fourth roots. Real fourth roots of, and you get, let's just say 1. All right. So again, you could type the 1 in your calculator, second y to the x, and 4, hit equals. And the real fourth root of 1 is equal to 1. And that's because 1 to the fourth is equal to 1. Now, if you're asked to find the real fourth root of negative 0.0001, that's the same as being asked to find this. The fourth root of 0.0001, negative. That's a negative under the radical to an even root. That's no real roots. The only roots that negatives can have are odd roots. The only roots that negatives can have are odd roots. Fourth real root of 16 over 81. So again, you can type this 16/81 into your calculator as a fraction. Second y to the x, type in a 4, hit equals, and we get 2/3. Right? And that's because the 4th root of 16/81 is equal to 2/3. And one last note. Even roots of a positive number are listed in the form positive, negative. Even roots of a positive are listed in the form positive, negative, meaning an even root, the square root of 4, that's equal to positive or negative 2. Okay? The square root of 16, all right, that's an even root of a positive number that's equal to positive or negative 4. The 4th root, that's an even root of a positive number that's listed as positive or negative 2. Okay? So make sure you're doing that when you're doing the practice problems today. Even roots of a positive are listed in the form positive or negative. Any questions? Your practice for today is going to be on page 364. Problems 1 through 3, and then 10 through 21. 1 through 3, and then 10 through 21.